All right, good morning, students. I want to briefly give us a small revision on Maths 101, and I will be starting from the topic that is called set. I want us to start from this topic. Let's start from this topic that is called what? Set. Okay? So we are going to move straight to the point. I don't want to waste much time by defining what is called a set, because each and every one of you know what is called what? A set. So we are going to start from types of sets. We are starting from types of sets. Types of what? Of sets. So the first one I am going to talk about is number one is an empty set. Is an empty set. So what is an empty set? Okay? An empty set, this is a set without any element or number. So any set that does not contain an element is said to be called an empty set. And these sets can be represented using this symbol. This is the symbol for an empty set, or we can use this to represent an empty set. So we should know that another name for empty sets, is called the null set. It's called a null set. So another name for an empty set is called a null set. And don't forget that. So what are the examples of this empty set? What are the examples of this empty set now? What are the examples of empty sets? Okay. If we are asked what are the examples of empty sets, I would want us to talk about the examples, because examples of empty sets. Examples of what? Empty sets. One, let's have that A is a set of X. A is a set of X such that X. A is a set of X such that X is a letter before an alphabet. X is what? Is a letter before and what? Alphabet. So when you look at this example, you could understand with me that there is nothing like a letter that you see before an alphabet. A. That is X is a set of A is an element of X such that X is a letter before an alphabet A. Good. Before an alphabet A. So there is no letter you see before an alphabet A. Okay, when you want to read something like A, B, C, D, E, F, G, H, there is no letter you will see before that particular alphabet. So it means that this is an example of what? An empty set. So there are some other examples of an empty set, which sometimes they can ask you this in exam. There are some other examples of an empty set. I have example 2. Let's have that. Let's assume that A is a set such that X, okay, A is an element of X. I have this that A is an element of X such that, this means such that X squared plus 1 is equal to 0. And where X is an element of what? Real numbers. So when we look at this thing is an empty set. It is an empty set because when you pick this, if you want to pick this number and you want to solve it, you could find out with me that X squared is equal to minus 1. And when you want to find the square root of this is square root of minus 1, which is going to give us what? A complex number, which is I. So S is equal to what? I. And you know that I is not an element of a real number based on this. So anytime you see this kind of question in exam, and you have it at S squared, what is differentiating these two persons is plus, and this is equal to 0. No matter anything that is here, except if he says it is a complex number, except if he says that S is an element of a complex number, But as long as this x is not an element of a complex number, it is said to be an empty set. It is said to be what? An empty set. So there are some other examples of an empty set, such that if I have something that looks like this, let's have this, a set of x such that x squared now, as long as this person is plus 4, which is equal to 0, and they say that s is an element of, even if I said it is a set of a natural number, or I said it is a set of a real number, it's still an empty set. The reason is because this is s squared plus 4 being equal to 0. Because if I want to solve this, I will say s plus 4 is equal to 0. Therefore, s squared will give me minus 4, and only my s will give me square root of minus 4, which will give me a complex what? Number. So it is also an example of an empty set. But if I have this, let's look at this. If I have that A is a set of x such that s squared now, and what I have here is not plus, assuming I have something like minus 4, which is equal to 0, and where x is an element of a real number. This is not an empty set. This is not an empty set. This is not what? An empty set. It can never be an empty set because if you solve this, you have that s squared minus 4 is equal to 0. Therefore, s squared is equal to 4. And only my x will give me square root of 4, which is equal to 2, or what? Or minus 2. So it means that the element of A is minus 2 and what? And 2. So this is not an empty set. Not an empty what? Set. This is not an empty set. So we need to be vigilant about this, okay? All right. The next one is a set of a finite set. Next one is finite set. So a set is said to be finite if the set can be counted. Any element in a particular set that can be counted, such set is said to be finite. For example, if I have that A is a set of number of states in Nigeria, okay? A is a set of number of states in Nigeria. This is called a finite set because we can comfortably count the number of states in Nigeria, which are about 36 states. So this is a finite set. This is also another finite set. If I have that A is a set of 1, 2, 3, 4. This is a finite set also because you can see it has an end. If you also have another set, let's look at it now. I have this as a set of x such that x is an element of what? Okay, let's say, let me pick this particular one now. A is a set of, I have A, B, C, D. This is also a finite set because we can count it. Are we together? Now there is also another finite set that one can also be asked in exam. Another example is if I have that A is a set of x. Now you come here and see that such that s squared minus 9 is equal to 0, and where s is an element of a real number. This is a finite set. This set is finite. It is not an empty set. Why? Because I can comfortably solve this to have that s squared minus 9 is equal to 0, which means that only my s is 9, and that my s is square root of 9, which will give me what? Minus 3 or what? Or 3. So this is my answer, which means that a set A now is an element of minus 3 and 3. So I know this, it is countable. You can see it is minus 3 and 3. So to say that this is also an example of what? Of a finite set. Okay? This is an example of a finite set. But if you have something that looks like A is, you have 1, 2, 3, and they put these three dots, it means that this thing tends to infinity, that you cannot count it. Like this means it tends to infinity, you cannot count it. Therefore, this is not a finite word set. So it is not a finite set, but rather we can say it is an example of what? Infinite set. So we can say it is an example of an infinite word set. So it means that an infinite set is another example of a set that we must talk about. Infinite set. Okay? An infinite set. If a set is finite, we say we can count it. It means it has an end. But if a set is an infinite, it doesn't have an end. So an example of infinite sets, you could have something that says 1, 2, 3, and you have this. This means that this thing does not have an end. It is infinite. It tends to infinity. That's what it means by that. So there are other ways they can put this thing. If you watch, this thing as set of natural numbers. So if I can say that A is an element of S such that X is, or A is a set of X such that X is an element of a natural number. X is an element of a natural number. Yes, this is infinite because the set of natural numbers are incountable. You cannot count them. So this is infinite also. Even if you have that A is a set of X such that X is an element of a real number. Yes, this is also what? Infinite. The reason is because you cannot do what? You cannot count it. Okay? So you must be up and doing. So another one that is very, very important in this revision class is also what we call equality of a set. This one is very, very important. Sorry. It's equality of what? Of a set. Now, when do we say that two sets are equal? Two sets are equal if every element of one set is also an element of the other set. I come again, two sets are equal if every element of one particular set is also an element of the other set. The order of arrangement here does not matter. Okay? So you can have some examples here now. Examples of sets that are equal. If I have a set A, which is 1, 2, and I have this to be equal to 3, and I equally have another set B, which is now equal to, we have 3, we have 1, and we have 2. When you look at this, you see that the order of the arrangements are not the same. But each of these elements that are here can be found here. So you find out that in this case, we can say that the set A is also equal to the set what? B. The set A is equal to what? Set B. Okay? This set A is equal to set B. Because every person I have here can also be found what? Here. Then if I have another example, let me say I have, for instance, now, let's assume that I have that a set A is equal to B M J I K, and I have that a set B is equal to, I have M J I B and the what? K. And you are asked to testify whether this set A is equal to B. Yes, of course, this set A is equal to B. This is because the set A, everything that is found on this A can also be found in B. The same thing are here, okay? So because of this, we say that this set is equal to this particular set, okay? So we can say therefore, a set A is equal to what? A set B. And remember that is what we call equivalent sets. Sets that are equivalent. I also want to use this opportunity to explain to you the difference between a set that is equal and when two sets are said to be equivalent. when two sets are said to be equivalent. Now, when two sets are said to be equivalent, it means that that same set, the two sets contains the same number of elements. What we consider in equivalent set is that they contain the same number of what? Elements. They contain the same number of elements, but though themselves may be different. In that case, we can say the set are what? Equivalent. So if I have this equivalent set, we know what is called an equal set. So when we have for equivalent, let's have this as equivalent what? Set. For equivalent set, we say that the number of elements in one set must be equal to the number of elements in the other set. So when something like this happens, we can conclude that the two sets are said to be equivalent. Now look at this. I have a set A, which is equal to 1, 2, 3, and 4. And I equally have a set B, which is now equal to, what I have is 5, 6, 7, and 8. Plus, these two sets are equivalent. They are equivalent because the number of elements in this set A is also equal to the number of elements in this set B. How? 1, 2, 3, 4. 1, 2, 3, 4. Meaning that their cardinality are what? Are the same. The cardinality of this set A is equal to 4. And the cardinality of this set B is equal to 4. So when two sets are said to be equivalent, it means that they must have the same cardinality. Their cardinality must be equal. Yes, we know that. When two sets are said to be equivalent, their cardinality must be equal. I also know that when two sets are said to be equal, when they are equal, their cardinality is also the same. Yes. So that is the major similarity between equivalent sets and a set that is equal. But they are not the same. Okay? Now, let us look at this. This set is equivalent, but it is not equal. A is equivalent, but it is not what? Equal. Now, I want us to look at this particular one. Let's look at this set now. If I have a set A, which is now equal to, I have it to be 4, 5, and 6. And I have another set B, which is now equal to, I have this one to be equal to what? 5, 4, and 6. My question is this. If these two sets are then said to be equal, the two sets are then said to be equal. Yes, these two sets are equal. They are equal because they contain the same elements in both the sets. And at the same time, these two sets are said to be equivalent. These two sets that is equal are said to be what? Equivalent. So this set here is equal and it is also what? Equivalent. Okay? They are equal and at the same time, they are said to be what? Equivalent. So what did you observe? We observe that any set that is equal, if two sets are equal, they are equivalent. If two sets are equal, they are equivalent. Like in this case. But when two sets are equivalent, they are not equal. Any two sets that are equivalent are not what? They are not equal. They are not what, somebody? They are not equal. Okay? So don't say that equivalent sets are equal sets. No. Equivalent sets are not equal. Okay? That is one thing we must understand between equivalent sets and sets that are what? That are equal. Now, the next thing I would like us to discuss is the cardinality of a set. Now, what is the cardinality of a set? The cardinality of a set is the number of elements the set contains. So the number of elements a particular set contains is called a cardinality, and it is represented like if a set A, the cardinality of a set A is represented like NA. So which means that I'm looking for the cardinality of this particular set. For example, if a set A is equal to 1, 2, 3, 4. And we are asked to find the cardinality. The examiner says, find the what? The cardinality. The answer here is that the cardinality of this set is equal to the total number of elements in this particular set, which is 1, 2, 3, and what? 4. So the cardinality of this set is equal to 4. But then there are some other things we must understand. There are some other things that we must do what? We must understand on this cardinality of a set. Now, let us look at this. Sometimes you'll be asked to find the cardinality of an empty set. Like the examiner can say, find the cardinality of an empty set. These are likely exam questions. An empty set is a set that looks like this. And it means that an empty set does not contain any person here, which means that the cardinality of an empty set is equal to 0 because nothing is here. It doesn't contain any person here. So I want you to take note of that the cardinality of an empty set, the cardinality of an empty set is equal to what? 0. Don't forget this. This is very, very what? Important. The cardinality of an empty set is equal to 0. And another thing you must understand from this concept is that when they say that A is a set of X such that X is an element of a real number, and the examiner says, find the cardinality. Find the cardinality. Remember that the cardinality of a set are the number of elements in that particular set. So if I want to find the number of elements in this set, which says that A is a set of X such that X is an element of real number. Numbers that are real numbers are uncountable. They are many. So we cannot count them. So because of that, I can now say that my answer is that the cardinality of this set now is equal to what? Infinite. The cardinality of this set is equal to infinite. So it is equal to what, somebody? Infinity. That is what it is. The cardinality of this set is equal to what? Infinite. So even if you see this kind of question and they are asking you to find a cardinality, you should know that the cardinality of this set is equal to infinite. Class, I would also like you to understand that if I am giving that a set A is also equal to A is a set of X, such that X is an element of a natural number, and then you are also asked to find the cardinality. We are asked to find the cardinality. The answer here, class, must also be equal to that the cardinality of this set is equal to infinite. The reason is because since A is an element of X such that X is an element of natural number, the natural numbers are uncountable. You cannot count them. So it is an example of an infinite set. It means that any infinite set must have a cardinality of infinite. So any set that is infinite, the cardinality of an infinite set is at infinite. So you must also try to note that anytime you are asked this question, which of the following is correct about cardinality? A, the cardinality of an empty set is equal to 0. Class, it is correct. B, the cardinality of an infinite set, the cardinality of an infinite set is equal to infinite, is correct. So any set that is said to be infinite, class, the cardinality must be equal to 0. That is what you need to know. So there are some other things that they can ask you to find the cardinality. Let's look at this. I have another example, like if I have example 5, where the examiner said that here is a set of X such that X is less than or equal to 7. And where X is an element of a natural number. we can find the cardinality of this particular set. Yet, of course. But before we can find the cardinality of this set, we must first of all get the element of this set. So if I want to solve this, I will say that my A is equal to. It says that X is less than 7. What are those numbers that are less than 7? And they are elements of a natural number. They are 1, 2, 3, 4, 5, 6, and what? 7. It says that S is less than or equal to what? 7. So this is what I have. And if I want to find a cardinality here, I will comfortably say this is 1, 2, 3, 4, 5, 6, 7. So the cardinality of A is equal to what, somebody? 7. Therefore, the cardinality of this is equal to what? 7. That's exactly what we have on this. At the same time, I will want us to look at this particular question now. Find the cardinality of these sets. Let's look at this particular set. Find the cardinality of this set. If a set A is equal to a set of x such that s squared plus 1, and I have a condition here, 1 is less than x. The set x is less than or equal to 5. Okay? Then we have to find the cardinality of this particular set. Believe me, if you are not careful, this question will disgrace you in exam hall. But I want you to know that you can solve this question comfortably by first, you must identify the element of this particular set. So when you see something like this, the first thing you will do is to write the element of A. What are the elements of A? Now, you will know that they say that s squared plus 1 is what I have. They say A is a set of x such that s squared plus 1 is what I have. And this is the condition that satisfies this. So what this simply means is that from 1, which is less than x, less than or equal to 5, the element of this 1 is that number that is less than, that is greater than 1, but it is less than or equal to 5 are 2 is greater than 1, and it is less than or equal to 5. 3 is there, 4 and the what? 5. That's exactly what I have. And then in this case, if I want to now consider it, it means that any place I see x in this question, I will put my 2. Because I already know that this is the first person I am having. So I'm going to begin to substitute those values. So, this is what I have. So any place I see this, I see I've captured every person here, which is 2, 3, 4, 5. These things satisfy this. So any place I see 2 from here, I will substitute. Now put 2 here, you have it to be what? 2 raised to the power of 2 plus 1, which is equal to what? 4 plus 1. So what I have here is 5. The first person, when I use this, is going to give me 5. So I'm going to try this 3. Put 3 here. You have it to be 3 squared plus 1, which is 9 plus 1 will give us 10. You use this 4. Substitute 4 here. You have it as what? 4 squared plus 1 will give us what? 16 plus 1, which is 17. And finally, carry this 5. Substitute 5 here. This is 5 squared plus 1, which will give me what? 26. So this is the element of this particular set. So if the element of this set is equal to this class, I can now comfortably say that the cardinality of this set is equal to 1, 2, 3, and 4, which means that my correct answer is equal to what? 4. That is the cardinality of this. I want you to know that there are many things you must know, you must cram. One is that the cardinality of an empty set, the cardinality of an empty set is always equal to 0. Another one is that the cardinality of an infinite set is always infinite. These two things are very, very important. Then let us talk about power sets. Power set is the next thing I would like to explain to you for the sake of this particular exam, so that you understand what we are doing properly. All right, the next thing I want us to talk about is the power sets. So I want us to talk about power sets. Power sets, okay? And what is a power set? A power set, the set of all the subsets of a given set is called a power set. I said the set of all the subsets of a given set is called a power set. I said the set of all the subsets of a given set is called the power set. Okay? Now, example here. We say that the set of all the subsets of a given set is called a power set. For example, if I have that A is a set of what I have is 1, and I equally have it to be 2, and I have it to be 3, and you are looking for the power set of this set, class, the power set of this are all the subsets of this particular set. That is what we define as a power set. Remember, the cardinality of a power set and what is called a power set are not the same thing. So in this case, if I want to find all the subsets of this particular set, all the subsets of this set are 1. I have it as this person is a subset of this set. Yeah. I have 2, which is a subset of this set. I have 3, which is a subset of this set. I equally have what? 1 and 2, which is a subset of this set. I equally have 1 and what? 3, which is a subset of this particular set also. Okay? So if you look at this, you see that these are all the subset of this particular set. Yeah. Because the subset of this set are this. And one thing I want you to know about subset is that an empty set is always a subset of any given set. Anytime you are looking for the subset of any given set, an empty set is a must, that empty set is a subset of that particular set. And another thing that you must know by convention is that every set is a subset of itself. So, class, if these things are the subsets of what I have, it means that these are the power sets of this. And if I've gotten the power set, watch, they are 1, 2, 3, 4, 5, 6, 7, 8. They are 8 in number. Meaning that the cardinality of this particular set of the power set is now equal to 8. That is what it is. This is called all the power sets. And if I now want to find the cardinality of the power sets, you must know that the formula for the cardinality of the power sets, cardinality, you know that the cardinality of a power set is given as 2 raised to the power of n. This is the formula for finding the cardinality of a power set, where this n is equal to the number of elements involved. So that if you are asked to find the cardinality of the power set, if A is equal to 1, 2, and 3, the examiner say, find the cardinality of the power set. Find the cardinality of the power set. So the formula I will apply here is going to be my answer. I will use 2 raised to the power of n. From here, what is my n? 1, 2, 3. So it will give me 2 raised to the power of 3, which is equal to what? 8. So it means that the cardinality of this power set is equal to what? 8. That is the formula you must use to find the cardinality of this power set. Now, if a set is an empty set, we know that naturally the cardinality of an empty set is equal to 0. because the number of elements in that particular empty set is 0. But if you want to find the cardinality of the power set of an empty set, the cardinality of the power set of an empty set, you know that an empty set is this. So what it will have is 2 raised to the power of what? 0, which is equal to 1. So the cardinality of an empty set. So look at it. It's talking about the cardinality of a power set of an empty set. The cardinality of a power set of an empty set is equal to 1. The answer here is that it is equal to what? 1. How? Look at it. This is an empty set. And what I have here, remember that the cardinality of the power set is given as 2 raised to the power of any. So here, any is equal to 0, meaning that what I will have is 2 raised to the power of 0, and which is equal to 1. So this is exactly what I'm going to be having. I want you to take care of this. I want you to share this video so that other people will watch it. Like and comment. Thank you and God bless you. Let's see in the next video concerning sex. Thank you. God bless each and every one of you. I love you all.